Okay, our next speaker is Philip Pearson, or Phil, as I would normally refer him to, Managing Director of UK-based lift and escalator consultants and Pearson Consult. He's been in lift industry and escalator industry since 1986, having previously been a building service engineer. Philip has experience of lift industry from all aspects, from client perspective, responsible for all lifts and escalators at large department store group, forming and running a lift and escalator company, designing lifts and escalators for lift manufacture, and 20 years as a lift and escalator consultant. Lots of experience.
Yes.
Looking forward to what you have to say to us.
Thank you. Is that your timer?
That's my timer, Phil. Yeah, yeah. You've got a lot of sides. I noticed. You're going to go really fast.
Very fast. Yes, that's also 50 years since I did my apprenticeship, so it's scary. Hi, good morning. And the presentation, as it says, is the technical challenges involved in lifting 40-ton trucks using rigid chain technology in a confined space. Two important words there is the rigid chain technology, which I know is a great interest, and the big challenge was the confined space. The rigid chain technology was quite straightforward. So why we're doing this presentation is to promote what we've done on this project. We've lived with it for 5 years, and it's going to form part of my CEng technical report presentation, which I'm doing. And I'd like to take this opportunity to thank my sponsor and mentor for her immense patience, Gina. Thank you. And I wish her a speedy recovery. And one day I will finish my CEng, hopefully shortly. So, whoops. We'll start. So the old ones in the audience will remember Dave Allen, the most politically incorrect person who sat on stage with his spag, his bottle, his glass of whiskey, telling totally inappropriate jokes. But one of the things he did say was, if I was going to go there, I wouldn't start from here. What does that mean with regards to this project? Basically, the starting point we got was not where we would choose to start. Ideally, you all start a project with a blank piece of paper and end up with the finished product. But in this case, we didn't. We started to be brought in by the client partway into the design process. So what is the project, and why do we need two 40-ton truck lifts? Basically, it's a theatre in Manchester. Not just a theatre, it's a 5,000 performance space. And just to make things interesting, the client decided to build it across the top of a public road. So the whole of the performance spaces are above it. The foyer is on the ground floor, where people enter. Then you've got the theatre and the warehouse at level 2, which is 6.5 meters up. Then you've got the towers at the back, which do the support, and the two truck lifts down the bottom corner there, which is a laser pointer here. Oh, sorry guys out there if you've got zapped. Yes, so you've got the two truck lifts here. The intention there was to be able to carry all the performance equipment up from the roadway up to the performance level. So what were the challenges? The design of the shaft was fixed when we got involved. Say that's the thing. If you're going to start a job like this, you're going to start it from scratch, not, here's the design. The shafts are all agreed and fixed by building control, although the planning has been all agreed. You can't change them. Okay, that's a good start. And then what the actual design we got was, this is the actual truck lift itself. And you'll see there the design with the mesh doors on it. Sorry, Richard. And the idea is that the truck would go up our dock level facility to offload the load here off the back of the truck. And would also, in addition, go up to the top level. The main flaws with this design was that the mesh doors prevented no separation of the outside air into the building and weren't secure. So we had to somehow integrate some security shutters. As soon as you started doing that, you see there, the size of the platform was reducing because the actual door having to come inboard and the flat surface being there for the form of the lift shaft. The roof was very low as well. So to get around that, we removed the roof of the lift. Why not? It's the early stage design. So we did away with the roof of the lift, and that then dictated the doors had to be a light curtain design because there's nowhere to hang any door hangers from it. So the lift operates with infrared light curtains at each end. But And then at the top, they had the rising barrier coming out of the floor because the main operation of the lift is from up here, minimal manpower, and at the bottom. So the next thing was the architect decided he didn't want these motors sticking out into the space. No, room with building lines, all the rest of it. Forget about street lights that's going to be on outside the building, other things like bollards, and nobody can see that part of the building. It's actually away from the public aspect. He wanted the actual motors inboard, so we lost some more space. So the platform was getting shorter. Then compounding that, the structural engineer didn't read any information or emails, and they said that the rising barrier, how unusual, that rising barrier being on the face of that top slab, and the top slab being set back, it had to come forward. So the barrier, the actual platform reduced again. You know, so it's all the time we're being squeezed. So by combining the roller shutter doors with the actual lift doors and getting away with the actual, or lift landing doors, getting away with the actual car doors, we managed to maintain the size of the truck. So another consideration was where the actual lift was positioned. This is the actual access road coming into it, was fixed. Planning consent, can't do anything about it. That's where it is. Live with it. Well, unfortunately, that's great. But we did a tracking company tracking, and there's these pinch points here where it would actually hit the side of the truck lift wall. So that meant it had to then go through up the access road down the side and then reverse into it. Now, this is a 40-foot truck. It's not a car reversing. It's a big thing. So those are the challenges, but you know, we got over them. So the items to be carried. Articulated trucks, yeah. One of them looks quite impressive when he's passed on the motorway. Wait till you see it close up in your lift, then you realise how big they are. And it's got to be basically carrying it fully loaded at 40 tons. So we looked at that, you know, we're lift engineers, but we said, well, you can only carry that. How big does it need to be? So we looked into the regulations, the UK ones and European regulations, and worked out they could be 16.5 meters long by 2.5 meters wide by 4.4 meters high. Gross weight of 44 tons. So at least you know what size we had to maintain the lift platform at. And then we got a bit of a win. The client says, we'll only limit to 40 tons. Thank you. Oh, what you do? Yeah, we're going to down to 40 tons. So that was the design. That's what had to fit it. In addition to that, they wanted the production equipment. So when they have these wonderful sets, you see, they made well onto assemble them in the yard outside and then bring them in. So I said, that's okay, as long as it's small in the truck. And also nothing to lean on the walls. Because we'd taken the roof off the lift, the walls weren't designed to take any side loads at all. You know, so we said, that's it, fine, you can use it for production equipment, but don't lean it on the side walls. How long that will last for, who knows? So, and then the other challenge, drivers to stay in the cab or not. When we inherited the job, we said, well, where's the staircase to the drivers to go from ground level up to level 2 to get back in his cab? Oh, that was VE'd out. How unusual. They took the staircase out early stage of the job. So the truck driver would have to walk into the theatre, go up the flight of stairs, walk through the theatre space and onto the lift, and then back onto the platform, which is at top leveling. Bear in mind that these performance people can be European drivers, you know, so they don't make English may not be their primary language, and somebody there trying to guide them through, totally impractical. So we said, we need to drive the cabs. So we looked at that and said, okay, what does that mean? So we come forward to this fire strategy, which changed halfway through the project and suddenly went from drivers staying in the cab to drivers not staying in the cab. Good old fire engineers. And then we had to persuade them that it was the right thing to do. So we did a cause and effect system on the lift. So the fire happened, what would happen? And then the other thing was, you know, obviously contacted the rescue service. It was quite straightforward, really, but all the challenges. And they end up doing a personal evacuation plan. The lift engineers, and all of a sudden you're doing a peep because nobody else is putting their hand up to do it. And to get the project across the line, thought, we'll do it. So we did the evacuation plan for the driver when he's in the cab, and there's a fire occurs halfway up, what happens? But what we actually did, though, as part of our mitigation, as part of our cause and effect, was to make sure when the truck rocks up, there was a 360 inspection of it to make sure there's no evidence of heat or fire on the truck. And then as it backs into the lift, there was a further inspection to make sure none of the running gear was overheating or smoking. And then the actual travel of the lift is only 83 seconds. And then because it has a dock level facility, which is 1.2 meters down from the level 2, Howard's driver, which all aren't always healthy, fit guys. There's some usually a bit on the rotund side, get from there. So we had to design a demountable ladder. So it's been a real challenge. And then the scissor lift or rigid chain, the interesting bit. We're all familiar with the scissor lift. That's an underside view of an equivalent size lift with the showing the, obviously it doesn't show the hydraulic power pack because that's in a separate area, or the rigid chain. Whoops, well, you missed that bit, guys. There's the rigid chain, and the important bit are these things. It looks totally impractical. That is one of the lifts under construction. The lift platform is at the top there, and you can see there the drive shafts and the motor at the end. And it's got the guide rails at the side to stop it, any lateral movement. And so we said, okay, that looks pretty interesting. What's the advantages? Why should we go for rigid chain? And the first thing we looked at was the scissor lift for the power pack. It needs a large space for the power pack. These power packs traditionally on these saddles, usually rather typically on these sides of lifts, are like a small combo van, and that's just the actual power unit, not the control panels. So they're and very noisy indeed. We've all worked with hydraulic lifts. These are hydraulic lifts on steroids. The great thing about rigid chain, all the equipment is in the pit. There's no motor room required. There's a control room. As I say, on the controls equipment, because the hydraulic lift has to be next to the shaft to stop any bounce on the hydraulic, etc., it has to be adjacent to it. Well, the rigid chain system can be near to the shaft. It doesn't have to be actually next to the shaft. So you got that flexibility where it actually goes. The complexity of the system. Well, this is an interesting one. This one, the people asked a question. A scissor lift is complex in its so far as to go to high pressure hydraulics operating to move the lift. Everything is stressed to the ilk. The scissor lift itself is stressed because the mechanical engineers, God bless them, have the rams where they can put them because it's strong enough to lift to that point. Everything is stressed to the point. On the rigid chain system, it's all proven technology, planetary gearboxes, prop shaft, chain sprockets, and it all just chunks along nice and slowly. Nothing's under too much pressure, and it's all proven technology. So it's complexity-wise, it's got a lot of moving parts. Obviously, the chain, instead of any lift, like an old chain-driven lift, it's got lots of moving parts on that chain. Bang about, it's a chain. It doesn't do a lot. The hydraulic system, the cooling it. We've all worked on hydraulic lifts, and again, big lifts, a lot of heat rejected, so you have to have oil coolers. And on the rigid chain system, you just got a fan on the end of the motor. That's it. End of any cooling required. And then the noise of the system. Again, hydraulic units, not well known for their quiet operation. And we went to look at a site in London which had a 40-ton truck lift with a scissor lift. And the noise in the motor room was noisy. We went to say, where's the oil coolers? Over the motor room door, it's a loading bay larger than this room, probably twice the size of this room. Yeah, they're over there. You could hear them with the oil blast coolers the other side of the loading bay. So noise is a big issue. Again, on rigid chain, the only noise is from the main motor, which isn't going particularly fast anyhow because it's an AC motor, and it's in the pit, so it's in a controlled area. So the noise-wise, and then the other one was the cost. Scissor lift higher than a chain set, rigid chain, due to confidentiality. Oh, running over. It's higher. It's a lower cost option to go for the rigid chain. How does rigid chain work? Basically, a link lift. So these are links that just click into place to form a rigid chain that goes around the sprocket, and it's like Rundian rope trick. That's the cassette it runs back into. So that's what it looks like. Open up. That's the actual units in the pit. And that's the unit in reality. The motor, transfer gearboxes, planetary gearboxes, and the sprocket drives here. And this is this noise of this. Can you mute the volume? I'll see if this works. This is the actual lift working. It's a slow inspection speed. So that's two lifts together coming down. That's both the lifts. And these are the support chains. It's very smooth indeed, and it looks wrong. You look at it, you think, how can that be safe? But it is. Excuse the random at the far side, what he was doing there. It's still a construction site, so the doors are not in place at this point. So that saves inspection speed, but it's amazing. See it operating, it's mesmerizing. I will cut that short. So what regulations and codes of this to go to? Machinery directive was the main one. The lift operates at 0.75 meter per second. It could go quicker, but when we looked at what we had to move with 20 trucks and for performance, that's quite fast enough for the time they had. There's emergency communications with EN 8128 compliance. Again, pretty straightforward. Safe worker on lifts. This is the issue which is always happening with the machinery directive, where the lift company says, oh, it's machinery directive, we don't need 7255 compliance. Well, there's still nice lads crushed under that lift, on that lift. So one of the challenges we have was actually getting the 7255 aspects incorporated in the design on our spec. And then the lift directive, and we use the NH 1-20 where it's applicable, because again, it's not a lift, it's a lift, but not a lift. So on the final bit, test and commissioning. There we go, split finish now. With on contract low, 10% and 25%. So there's quick learning, quick lessons. Involvement from an early stage will be essential. Being involved when the thing's all designed as a box is too late. Lift design company understanding lift standards and codes. That's always an issue because all of these companies are there for stage lifts and things like that, or equipment that doesn't need to comply with the codes. And half our battle was making sure that the codes were complied with. And this is an important, in this instance, getting the whole design team to sign up that that truck must fit in that lift when it works. You might be the architect and you might wander off onto another project, but that must work. And pleased to say the lift actually has moved a 40-ton truck. So that was a big. So thank you very much. And
thank you.